What specific problem does the proposed method aim to solve regarding the personalization of AI models using egocentric video data?
The proposed method aims to solve the problem of how effectively an off-the-shelf language model can learn meaningful personal information from a relatively small amount of egocentric video data, specifically without explicit annotations. By fine-tuning GPT-4o and GPT-4o Mini on time-stamped text summaries derived from 1 week of personal video footage, the study seeks to determine if such models can recover basic facts about an individual's life, such as their gender, age, and occupation, while also assessing the cost-effectiveness of this process. The experiment highlights the potential for AI models to infer personal details from passive data collection, addressing the challenge of personalizing AI in a simple and affordable manner. Additionally, it raises concerns about the model's tendency to hallucinate information, which underscores the need for responsible AI development in the context of wearable technologies. Ultimately, the method serves as a proof of concept for leveraging egocentric video data to enhance AI personalization, while also cautioning against the risks of misremembering details.
How does the proposed method work? Please illustrate the step-by-step process involved in collecting data, generating summaries, and fine-tuning the models.
The proposed method involves a systematic approach to collecting personal data, generating summaries, and fine-tuning language models. First, I wore an ORDRO EP8 action camera continuously for 1 week, capturing 54 hours of first-person video footage that represented a typical week of my life. After backing up the footage, I extracted 1 frame every 30 seconds, resulting in 6,480 still images. Next, I used the GPT-4o Mini X-Space model to generate text summaries for each image, focusing on details and context, and then created a hierarchy of summaries for different time intervals, minute, 10-minute, hour, and day-long, by combining these image summaries. Finally, I fine-tuned both GPT-4o X-Space and GPT-4o Mini X-Space on the timestamp summary data, allowing the models to learn about my daily routine and infer meaningful facts about my life through next token prediction, all while adhering to a budget of 100.
Can you provide a specific illustrative example of how the fine-tuning was done using 3 days' worth of video data? Walk through the key steps and explain how the model learned from that data.
The fine-tuning process using 3 days' worth of video data involved several key steps. First, I wore a camera headset continuously to capture first-person video footage, which was then backed up to my laptop. From this footage, I extracted 1 frame every 30 seconds, resulting in a total of 3,240 still images. I utilized GPT-4o Mini X-Space to generate text summaries for each image, prompting it to describe the context and details in 3 to 4 sentences. These image summaries were then aggregated into minute-long summaries, which were further combined into 10-minute, hour-long, and day-long summaries, creating a structured hierarchy of 3,625 summaries. Finally, I fine-tuned both GPT-4o X-Space and GPT-4o Mini X-Space on this summary data, allowing the models to learn about my daily activities and infer personal information by predicting what I was doing at specific times, even without explicit details being provided.
What are the theoretical or practical benefits of using the proposed method compared to traditional approaches to personalization in AI models?
The proposed method of using egocentric video data to fine-tune language models, as demonstrated in this paper, offers several theoretical and practical benefits over traditional personalization approaches. Firstly, it allows for the collection of personalized data without the need for explicit annotations, enabling models to learn from a single individual's life experiences over a week, which contrasts with traditional methods that often rely on labeled datasets. Secondly, the approach is cost-effective, as evidenced by the total project budget of 100, making it accessible for individual users and small-scale applications, unlike many traditional methods that require extensive resources. Additionally, The fine-tuning process through next token prediction on temporally structured summaries enables the model to infer meaningful facts about the user's life, such as their occupation and preferences, without direct supervision. This method also highlights the potential for models to learn from passive data collection, which could lead to more intuitive and context-aware AI interactions in daily life. However, it also raises concerns about the model's tendency to hallucinate details, emphasizing the need for responsible implementation as wearable technologies become more prevalent.
How was the effectiveness of the proposed method validated? Describe the experimental design, datasets used, and the metrics that were utilized to assess performance.
The effectiveness of the proposed method was validated through an experimental design where I wore a camera headset for 1 week, capturing 54 hours of egocentric video footage. This footage was processed to generate a hierarchy of time-stamped text summaries using the GPT-4o Mini XSpace model, which were then used to fine-tune both GPT-4o XSpace and GPT-4o Mini XSpace. The validation involved querying the fine-tuned models with a set of personal questions that varied in complexity, assessing their ability to recall factual information and make inferences about my life. Performance metrics included the number of questions answered correctly, approximately correctly, and incorrectly, with a focus on both surface-level traits and more complex inferences. The results indicated that GPT-4o XSpace outperformed GPT-4o Mini XSpace in accuracy, particularly for questions requiring multi-day aggregation or contextual interpretation, demonstrating the method's potential effectiveness in learning from personal data.
What specific results were achieved with the proposed method, especially in terms of the accuracy of personal information retrieval and any notable hallucinations observed?
The proposed method achieved notable results in personal information retrieval, particularly with the fine-tuned model GPT-4o, which correctly identified key facts about my life, such as my residence in Pittsburgh, my status as a PhD student at Carnegie Mellon University, and my nut allergy. GPT-4o answered 7 out of 13 personal questions correctly, while GPT-4o Mini only answered 2 correctly, indicating a significant performance gap. However, both models exhibited hallucinations, fabricating names for my cat and significant other, and misidentifying my personality type. For instance, GPT-4o rationalized my age as 28 based on lifestyle factors, despite the logic being incorrect. These results highlight the model's ability to infer personal details from limited data, while also cautioning against their tendency to confidently misremember information that was never explicitly provided.